Hey guys, this is YouTube video, and we're going to look at a very detailed proof of the function here that we derive. This is why the formula works if you're working with hyperbolas. This is a special case of the ellipse, which is a special case of the circle. It is a type of circle course, but this is a special case. And I want to take my time explaining this. What we had to do, right? We want to work this backwards to get back to that circle somehow, some way. And from there, we're going to do a lot of manipulations here and make sure each step is taken carefully. Looking at each piece to see how each related and fits into a whole. Okay. Here, we have to prove that same proposition is in more detail. And what we are looking for, we're trying to prove that this function is, or this formula says what it says, right? And this has some major mathematical consequences. And this is an equation result from physics. In 1930s and 40s, physics and mathematics took their separate parts, right? Separate ways, how you want to look at it. And this is a part of the proof still. This is various parts of the proof. And again, this is a very monstrous equation here. And I'm just amazed by this, how this thing works out. I'm just going to walk through this. So you guys have any questions, put in the comments. Again, this is a derivation of the formula of the hyperbolic function and proof of it as well, why this formula works. And this also deals with, like I said, some physical and mathematical concepts. So this is a really monstrous proof. So I'm taking a little longer. So let's give you guys a chance to really get a good feel of the proof here. So we have students in the background, so I'm trying to keep my voice at a certain decibel. So it took up all these board space. And like I said, everybody have different styles of looking at things. This is my way of looking at the hyperbola. And there's some verification stuff right here. So if you can't see it, I'm doing the best I can to show you guys what's going on. Okay? It's really cool. Now, if I really want to do some details on this, I would need probably the whole room to fill this up. This is no joke. It's no joke, guys. It's without a calculator. And this is how they probably did it in the 1950s. And you want a more formal proof, an analytical proof, you can look in your the calculus book or a college algebra book with the coordinate proof. I think this would be better than these geometric ideas and concepts to really elucidate the facts here. And you can easily see what's really going on. And look at my previous videos, guys, and to give you a better visual. But this is more of an abstract way of looking at hyperbolas and stuff like that. And so, yeah, so we can sit down and talk about it a little bit and what a hyperbola is used for. And stuff like that. So hyperbola is basically used for a lot of things. Sound waves, right? Orbital, probably planetary orbitals. Object approaches the Earth. Satellites. Sonar technology. So that's probably even designing automobiles, like the bodies of automobiles and stuff like that. And it's also used in complex analysis too, the hyperbolic function. And you guys are in for a treat. So if you're studying calculus, this is basically a big old calculus problem. We just use a lot of sophisticated algebra here. Just proving that one proposition, okay? And that's not an easy task. Cause I'm trying to determine where that formula comes from, and that's our proposition, guys. So we had to do some working backward and stuff here. So first you got to work with the signs and all that. So you really have to know your algebra. So there's algebra, geometry, and pre-calculus, guys. And that proof goes all the way back there. It's infinity long. And what makes this thing so unique, it's very different from other textbooks. Yeah, it makes it so cool. And it's best to do a proof on your own so you can understand it. Don't worry about what anybody else tell you. If your proof is good enough and it's logical and it complies with all the rules, which is, I think, this overstep its bounds when it comes to compliance. Yeah, I had to put in some formal language and logic in this stuff. Again, it's at the undergrad level, probably a graduate level to stuff too. So if you're a grad student, you probably appreciate this more, and you probably make some minute corrections. I understand. This is really a sophisticated proof. And you might, I'm going to caution you this, you might have problems with this a little bit. And some of this might be circumloquacious in the way that it goes back to its original point. But I try not to go that route, But I want everything follow each other. And make sure everything comes together, one beautiful piece. And stuff like this really is important in mathematics. This is definitely could qualify for an article, right? And I'm thinking about doing that in the future, write an article on this. And I'm going to show you some ideas. So let me go ahead and pause this.